once again. Alright, so today we are going to rebuild the Nextruder, or rather the X-Carriage and the Nextruder. So in the previous stream, what had happened was we assembled everything, and we found that the X-Carriage was actually a little bit too tight. So this piece right here, looks like this might be a little bit too high. Let me modify the setting. Will this do any better? That is very laggy. Alright, I think we are back. Alright, it's not complaining that things are too slow. Alright, I think I removed the lag in the video. Alright, so in the last build, we went ahead and assembled everything, and as you can see, we actually made it really far in building this thing. We went ahead and assembled the carriages and everything, and right as we got to the fun part of assembling the Nextruder, these screws right here were off by the slightest amount. I was able to get this screw in and this screw in, but this one, the screw itself was going in a little bit lower in comparison. And granted, this is missing the standoffs here, but the misalignment was there, and it was maybe by 0.2 millimeters, enough where the screw didn't want to thread, and also enough where I didn't want to force it, because then that screw would not go in straight, it would be at an angle. So what I've done is I've reprinted this part and many other parts using known settings from a previous build. So our goal today is going to be to actually just undo what we did earlier. We're going to go ahead and we're going to rebuild the Nextruder here. We're going to put it back on the carriage. We're going to test the fit on all the parts. And what we're going to try to do is just get to the point where we can mount the Nextruder on the X-Carriage assembly and go from there. So let's go ahead and get started. We're going to have to reference the guide backwards to go ahead and see kind of the things that we missed. I want to make sure that I don't miss any of the important pieces, specifically around these X-Carriages and how they're aligned. So the fun part is you'll get to see all of that again, and by reading the guide multiple times, it'll just help us better understand it. Move that cable out of the way. I don't want to damage this Nextruder cable either. So let's go ahead and try building this thing right here. So in the browser, we're going to have to go back a little bit. I think we're actually going to have to go back to the X-axis and the X-Carriage assembly pieces. Look at that, we almost made it to installing the hot end. How fun would that have been? Alright, we've lubricated the bearings, covering the bearings X-end motor, we've already installed that, installing the X-axis, assembling the X-Carriage parts preparation. I think this is where we are. The nice benefit that we have with all of this is that I have all the components already on the desk ready to go. They are just mislabeled, so there are a few things we might have to measure. Some things should be pretty obvious. I tried to keep them close to one another. So let's go ahead and build this X-Carriage right here. So the X-Carriage needs the square nuts inserted into the part. Let's start with this piece right here. So here's all the parts that I took out of the X-Carriage. Fun times. I'm going to grab a square nut, and I'm going to insert them here into the top. I was actually a little bit worried these might be falling out, but that was a really nice fit on that one. That one slid in and feels wobbly, but it's not coming out. So I'll call that a win. And then this piece right here, it went in. There's enough friction on there where it's not falling out. Alright, moving on to the next one. We're going to have to install these square nuts from the bottom. So flipping the part, looking at the bottom, we're going to install that square nut and those two right there. We're going to go kind of fast because we've already done this once. I don't know how small your hands have to be for this to be easy, but that one is not holding it at all. So that'll be a fun one to build on the printer where it's constantly falling out. I don't think there's anything I could do. I'm not going to use super glue on this. It would just be a terrible idea. And then you have to take it apart or something. Alright, and this one right here. Get that one friction fit. That one's not coming out. Let's do one of those Dairy Queen tests where they flip it upside down. Yeah, we're good. Not coming out. Alright, back to the browser. And the final two, I think we already did those. So what did we miss? On both sides, we just need to make sure we do these square nuts. I assume the other side will be also not very tight, therefore they'll just pop in. Oh! There's something with that hole that made it hold it. But as you can see on the other side, they've already fallen out. So I'm going to leave those out. I'll know to add them later. This one's also popping out. Just like that. So we will actually have to add them mid-build. Alright. What is the next step here? Next step, attaching these spacers. So these are just going to be M3 nuts. They are not actual spacers, and they want us to use the screw pulling technique. It looks like M3 by 10 screws will work for this one to install. So we're going to install these two here first, and then we're going to move on to the installation of the larger spacers. So the ones that we're looking for is this one right here, and this one back here. So let's pop this one right in over here. There is quite a bit of space in this part too, so it doesn't want to stay in there. Alright, plan number 2. Grab an M3 by, whoa. It wants us to use an M3 by 10 for this, but look at that. It doesn't even go all the way through. So we're going to have to use something a little bit longer. At least I think these are M3 by 10. I might have to go get my caliper for these. The other thing that I noticed is a lot of these screws have a little bit of plastic on the threads. I think some of the holes were just a little bit too tight. So look at that. That one just barely made it through. So let's go ahead and thread this on from the top. I'm applying a little bit of pressure on the top so I can get the threads in, but I'm not pushing it into the thread holes because that'll happen right here. So using that screw pulling technique, we have the nut right there, and we just tighten. And let's watch that thing go right in. Look at that. Looks pretty good. Alright. And I am going to tighten kind of far because I want that thing to go somewhat all the way. Okay. And that part is not coming out. So we are good there. Now, working on this part right down here. Same logic applies. I think I'm using an M3 by 18. And there should be another nut somewhere here. And if you didn't follow my recommendations as in the past, good. I think the screw monster might have ate this one. Yep, found it. It was on the floor. So they go ahead and give you extra ones specifically for situations like this. So again, just going to hold it from the top and start tightening it in from the back. And then you can watch it slowly make its way. You do need to hold it so the sides engage with the wall, but then once it's in, look at that. It's actually a very nice feeling with the screw kind of being pulled inward. It just looks so cool because the fit on it is just so exact because they want to friction fit these screws. And with the Galaxy ABS, the parts themselves look more matte, and I think they do have more friction, but on some of the fits, you know, they don't necessarily slide in, but they do feel really nice. So, all right, we've got that one in. Screw goes back off to the side. Let us move on to the next piece, where we install the standoffs. So it looks like this one might be an M3x10. And I think we're actually going to leave the M3x10 screws in there. Yeah, so there's 3 of them. There's 3 of the nuts. We are definitely leaving those screws in there, and they are not coming out. So let's go ahead and install this one first. And it doesn't look like there's any sort of rules to installing this, not that we're applying any sort of pressures onto it. So 3 spacers, 3 M×10 screws. Let's start with the middle one. That's my favorite one. We're going to pop this in right there to the point where the screw pops in on the other side. You could see it there. Poor lighting. Working on fixing this video stream one thing at a time. So step 1 was the camera. I hope that the camera here is of better quality. I also have it on a better stand, so I can better manage and work around it and be closer to the parts, so I look like I'm fumbling less. But this camera does have a battery, so you know, that's fun. Got to manage a battery now. Next is most likely going to be lighting, and I already have ideas on how to potentially fix the lighting. The lighting in this room is all right, although I think we need a light to see how we're building. All right, here's our next M3x10. Let me get my direction straight. It is this one popping out right here. And I'm going to put this nut right on top of it, or this spacer. I think it's a spacer. I'm going to pre-thread it really quickly right now just so it pops in. And then going to go ahead and align it and tighten it all the way. I am much happier with this fit. The last one, when I was tightening any of these, the screw going in was going just in a little bit too tight. I think this one is looser. And what I'm hoping is that because it's looser, the alignment on the holes will be right. I did look at the alignment prior to completing this assembly, and it looked to be a lot better. Looking through the holes, they at least aligned correctly based on just visual inspection. So, and also, you know, we were not off by a ton in assembling this. So, let's go ahead and get this piece on. I'm also moving a little bit faster in this build compared to previous videos because I've already done this. I feel comfortable doing this. I think with these printers, the nice thing is if you ever do maintenance in the future, you know, always buy the kit if you're technically inclined and you know how to do this, or you can read the manual. The manuals are fantastic. And in the future, if something breaks, you know, you'll feel more comfortable taking it apart because you built it yourself, so you know, hey, I have the capability, if I had to tear this whole thing apart, build it again, that I could do it. So I could probably fix this problem, or I can probably fix anything that this thing throws at me. So standoffs are good. I think, you know what, let's go ahead and do the test now, because this is what's bothering me the most. making sure that this piece fits. And from the looks of it, you know, I'm looking down all these screw holes and it's looking mighty fine. Let's make sure we actually got it right. So this screw was the easiest one to attach because it always attaches. This screw I was also able to attach. It's just this top one or the bottom one, once one was attached, was no longer aligning. So let's see, let's get that one attached. Make sure not to tighten your screws so you can actually move these around and get them onto the threads. Yeah. Watch it not fit again. I'm just gonna look really stupid again. Okay, the top one attached. The bottom one is not going in. What gives? The alignment on it is correct. Or is it? Yeah, I'm looking at it right here and it looks to be aligned properly. Let's look into the hole. Yeah. I can see everything that's in there. Let's try a different screw. Oh, come on now. Maybe I tightened these a little bit too far and it's having trouble falling into the threads. Or maybe it looks like the alignment might still be off by the slightest amount. Oh, right there. It's right there. Come on. Why don't you want to screw in? No, the alignment is on this one also off. Wow, okay. Although it looks like this part might be too big, too small. Wow, okay. Huh. Yeah, look at that. We got another part. You know what? I think that this bottom piece, the standoff actually looks not to be straight. Let me try straightening out the standoff. Because I think with this one, this might be one of those situations where the standoff being just a little bit off. I mean, tolerances are super tight. The screw, basically, you know, it's really hard to see, but the screw is like right off center by maybe just a little bit. So I'm going to try pulling this standoff closer to the edge, which should then go ahead and pull everything else. Or maybe if I loosen these standoffs in the back a little bit, I can get them to align and then I can tighten it. So let's try that. Oh, that looks to be okay. That one went in. That one went in. Huh. Interesting. Wow, talk about tight tolerances on these. It really did not want to do those. Even going in, it's a little bit tight. See, it's even pulling this one. So let's see, I need this part to be a little bit smaller. Because these two need to be a little bit closer to one another. Okay, well I got it installed, and the thing that I am a little bit worried about though is with these standoffs, can I later go ahead and screw them in from the back? So let's see, where's that part that goes in? So this piece will be on here like so, holding the bearings in place. And then there is a back cover for the x-axis that goes like so. Right? Yeah, like this. Let's talk about the fit on that one too. Well, yeah, it's going to fit together. Just needs to click in right here. Okay, and clicks in at the bottom. That looks pretty good. But now, are these screws accessible? This screw is still accessible. And then this other first standoff here is accessible, and this standoff is also accessible. So you can actually get in there with the tool to go ahead and adjust the standoff. Okay, I feel good about that. So if needed, we can adjust, although probably not too good of an idea. Let's see, where is that load cell from earlier? The load cell is actually up here. So applying stress is here. I think that actually might be okay. Although I am still going to try printing this a little bit smaller. I think I accounted for shrinkage, and I accounted for too much shrinkage. So go ahead and remove this part. Parts don't shrink that much. I wonder if we have the same issue with the Z-axis. I also printed those parts, thinking of reprinting them as well, because I had to drill out the holes, and it was the same problem where the alignment was off by just the slightest amount. So, one other piece that I reprinted that I actually wanted to take a look at was, let's see, this is an M3x10, the Nextruder over here, was the actual Nextruder back here, the Nextruder cover. So, let me see if I can adjust this in a better way for visibility. So let's move this a little bit further. I went ahead and I did print that Nextruder cover. I think this might be a really good calibration piece too, to see, are we good, are we too big? So here's this cover. Oh yeah. Maybe it's just me, but that feels significantly bigger. So it prints bottoms up like this. Let's go ahead and try putting it on. Yeah, the dimensions on that one were very off. Oh, and these screws are going to be super long, like 18mm ones. Unscrew it all the way through, and once we got it, keep going. And can I pull these off? I have a tighter piece, one layer lower, that is just holding on to these threads. Okay, got this piece. Now let's remove this plastic ring. So I don't damage this plastic ring. There we go. Just got to prop it up from one side. It is a not a printed part. So, and is it going to pop into my part? No. My part now, the outside actually has more than enough room, but the inside circle is a little bit too big. So I think from a size standpoint, I think we've just validated that the parts printed are too big. Also, let's look at these parts really quick. I'm going to pull these screws out, and we're going to do a comparison of size. So just looking at the XY size. Looks like I might have to go back to the drawing board with this one more time, because look at that. That's I'm trying to, okay, I'm going to hold the bottom flush and the side flush. You can see that that is a significant difference in size. And these screw holes are off by just the slightest amount. The slightest amount where the screw going through is going to have too much tolerance. So, alright, looks like we are going back to the drawing board. So this was fun. I actually thought we were going to get this done today. See, I might actually, so what I'm doing with these parts right now is for this top part, or rather for all of them, I have two different settings. So one is the part scale, and then two is accounting for ABS shrinkage of the part. I think maybe what I might try to do is maybe I'll just do the part shrinkage, because part shrinkage takes into account just, hey, the properties of ABS are a little bit different, but in comparison to PETG. So, oh, I forgot to add this piece. I'm going to add that in because knowing me, I will forget. I'll just use this one thinking, oh, it's a great idea. And then I don't know where my gears will be grinding. I'll have to buy a new planetary gear. So yeah, I think I'm going to try to not scale all the parts. I'm going to just let the slicer figure out the parts themselves, the shrinkage of ABS. So it's going to apply some sort of calculation and say, hey, ABS shrinks, therefore the part should be this size. And I'm going to try to print those. And the one thing I'm actually going to do before trying to do a stream again is I will take that part that I printed, specifically this X-Carriage. I'll just print that one first. We'll print it out, we'll go ahead and assemble it, and I'll try to mount it on this piece. I think that'll be a really good litmus test to say, hey, does this thing work, does it not? And it'll just help validate some assumptions. And I think if these three screws align and other things also align with the part, then I'll be happy. Let's see, this part prints, let's see, the orientation prints like that. So for this part, the Z height is going to be controlled by the printer. Therefore, it is not susceptible to the shrinkage of the axis. But the XY, and that's I think why we're seeing this problem right here, is going to shrink. So what I've done is I've scaled the part, which scales both axes, and then I've also applied shrinkage, which goes ahead and adjusts that. But with shrinkage, what we should be able to do is just adjust that. Now with the, let's see, these parts probably aren't falling out right here because it's on the Z-axis. But these parts right here, no, it's the same axis that they're being printed on. Unless the thickness left-right is too big and also too tall. Yeah, I guess with this one, the part is going in through the top. So the top height is good, and the X and Y, while scaled, it still pops in. But this one is falling out. And then I'll also actually reprint this part. I think another thing that will help validate is if I can get this part to be the same size as this part right here for the X and Y, and I mean, I could feel how different this one is, and I feel like it's that amount. I'm going to go grab calipers and measure it here in a second, but I think the amount that I'm scaling it is going to be how big this part is. So, so it's essentially being scaled twice, and we only want it to scale once. So I'll also print this part. I'll reprint these two. If I can get both of these working correctly, making sure that this washer fits in right there, no problem, and that I can mount the Nextruder onto the X-Carriage, no problem, and also a few other nice things, I will go ahead and potentially reprint more of those parts. I will actually look at some of those parts, because some of them are not that critical, like the LCD screen cover. I think as long as the LCD screen pops in, I'll be happy. I won't waste the plastic and print a new one. But I want to make sure that all the Nextruder parts, that they are, you know, really tight within tolerances. I wouldn't want that not being correct, and that'd be important to get right. So, thanks for joining the stream, and I am gonna prepare better for the next one. Bye now.